Today we're going to talk about how to identify branched alkanes. We're learning this so that we can add other functional groups and substituents to hydrocarbons later on. And our success criteria is to be able to name and draw the branched alkanes. So all straight-chained alkanes longer than propane have what we call structural isomers. A structural isomer has the same formula but a different shape. They're composed of the same atoms and elements in the exact same proportions, but they're rearranged in a different way. So, for example, both butane and methylpropane have the formula C4H10. But methylpropane has 3 carbons and then 1 carbon branching off of the middle. So it's structurally different. It will have different physical and chemical properties. They'll still be fairly similar, but there will be differences in how they react and behave. As hydrocarbons become more complex, they get more and more structural isomers. So butane only has 1 structural isomer, but then pentane, which is only 1 carbon up, it uses 5 carbons, actually has 2 of them. And then hexane has 4 of them. When we are identifying these compounds, we actually name them in 2 parts. We name them both off of the parent chain, which is the longest continuous line of carbons, and we name the branches as well. And we will eventually be giving locations to those branches so we know where they are off of the parent chain. Branches can always be identified because they end in the suffix YL, and the names of organic compounds end up being kind of like compound names, compound words. So when I say methylpropane, that tells me the structure of the compound right away. I have a methyl, which means I have a single carbon branch branching off of a propane, which is a 3-carbon parent chain. Now, it is possible for there to be branches upon branches. You can sometimes get these fractal-like patterns within organic compounds, but we don't cover those in Chemistry 30. That is a topic that we leave for university. When we name a branched compound, first thing we have to do is we have to look for the longest continuous chain of carbons. And we have to be careful with this because the longest continuous chain might not be a straight line. In fact, the diploma exam sometimes loves having these twisted things that zigzag back and forth, making you find the parent chain and throwing you off track by having it have bends in it. It's not necessarily a straight line. Once we determine the length of the parent chain, we can actually get the name of that parent chain right away because it's the same as naming an unbranched alkane. It's the number of carbons creates the prefix, and then the type of bonds in them, here single bonds, gives us the suffix ane. Once we've done that, we also have to determine the locations, the numbers, and the lengths of any branches off of the parent chain. If we have more than 1 branch of the same type, we have to add a prefix in front of the branch name as well. And these are the old molecular prefixes that you're familiar with: di, tri, tetra, penta, hexa. We always also have to give a number. The number tells us the actual location, which carbon it's bonded to. And we want to always keep the numbers as low as possible. And I'll show you what that means in more detail in the sample problems. Finally, what we're going to do is we're going to write out the name in a very specific format. We're going to write the branch location's number first, followed by a dash, than by the branch's name. If there's more than one branch, we'll repeat that format multiple times, and we do it in alphabetical order. And then we end the name of the chemical with the name of the parent chain. There's only ever going to be dashes as separations in an organic compound's name. We never use spaces at all. If we need to draw a branched compound, it's actually a bit simpler. First thing we do is identify the longest straight chain of carbons in the compound. After that, we will attach branches at the numbered locations that are indicated by the name, and finally we'll add in our hydrogens so that all the carbons have 4 bonds in total.